Hey everyone, so today we're talking about lesson 6.4, and our topic is which is the best method. Now, when we talk about solving systems of equations, there are three methods. We've discussed two of them in class, which is the linear combinations and the graphing method. But there's a third method called substitution, and it's exactly what it sounds like. You're going to solve for one of your variables and substitute that solution into your equation so that you're dealing with one variable as opposed to two. So our target says I can write a system of equations to represent a problem scenario to be able to choose the appropriate methods to solve. So what we're going to do is look at one system of equations, and we're going to solve it two different ways, and we're going to kind of look at the similarities and differences. So the first system that we're going to look at is the function 1/2 x minus 5y is equal to negative 31/4, and 2/3 x minus 2y is equal to negative 21. Now, the two methods that we're going to focus on for this problem are linear combinations and linear combinations is really, it just means that we're going to use the coefficients to eliminate a variable. So that's when we multiply the whole equation by a new factor so that we can eliminate a variable. And the new method that we're going to look at is called substitution. And substitution means to isolate one variable and plug it in for the other. So essentially we're going to take a variable, we're going to solve for that particular variable, and then we're going to substitute in the equation that we got. So for both of these methods, because our system of equations have fractions, we're going to start the same way. We're going to start by multiplying each equation by the least common denominator so that we eliminate those fractions and they're just a little easier to work with. So the first equation has a denominator of 2, 6, and 4. So your LCD would be 12. Second equation has a denominator of 3. So obviously your LCD is 3. We're going to multiply through and simplify those fractions. And we're going to write out our simplified function, which is 6x minus 10y equals negative 93. And then for our second function, we end up with 2x minus 6y equals negative 63. So that's basically the same first step no matter which method you're going to use. If you're going to substitute or you're going to use linear combinations, you're still going to start by eliminating those fractions. Now we're going to proceed with the linear combinations method. So I'm going to start by changing the coefficient of my second equation by multiplying by negative 3. I get negative 6 plus 18y equals 189. And now I'm going to eliminate my x terms and solve for y. So I get y is equal to 12. And I'm going to substitute in that value to one of my original equations. So I'm choosing to use 2/3 x minus 2y equals negative 21. Instead of the y, I'm going to substitute in 12. Solve for x. So I get x is equal to 9/2. So my solution as a coordinate point is 9/2, comma, 12. Now I'm going to go back to my substitution method. Instead of using that coefficient, I'm actually just going to manipulate the first function that I have so that I'm solving for x as opposed to having that whole equation. So first thing I do is divide by 2 to get rid of the coefficient on the x. Divide all my terms. Now I'm going to move over that y term. So I get x is equal to 3y minus 31.5. If those two halves of my equation are equal, then I can presumably substitute the x value in my first function for 3y minus 31.5 and rewrite that equation so that I only have y terms that can be combined and solved for. So as I distribute that 6, I get 18y minus 189 minus 10y equals negative 93. So I get 8y is equal to 96, and again, y is equal to 12. Notice that's the solution that we got on the first method, the linear combinations method. So we're on the right track. I'm going to pull one of my original equations for x. X is equal to 3y minus 31.5. Substitute in the y value of 12. Sorry for the visual. That's going to adjust in just a second. So we can copy down x is equal to 4.5 or 9/2. And the last thing we just want to mention is that the method of graphing is going to be key on problems where they ask us to compare the systems. So if they want to know kind of what the break-even point is, you can do linear combinations or substitution. If they want to compare, you want to choose graphing.